Hello, hi, and I'm back. And I thought, before I continue with the technical experiment, this is an iris. You can make it with pipe cleaners and a stapler and some silk cloth from Fabric Land or Fabric. And this is Charmy Satin, and I've reversed it. No, too silky look. I didn't want. And I'm trying to recreate my lab here. All my past friends, colleagues, and a chemical engineering hubbub of activity. This whole, all right. They're all working, work. No shirking, no shirk. And yeah, so this, and I've sprayed some glitter spray there. All right, because I kind of thought I was the jelly in the Tootsie Roll. So let's see. All right. So just an aside. So strictly serious from now on. All right. So to interplicate. So again, glutamine, arginine, lysine. You've seen my boxes here. I think it's going to be doing. Let's see if I can move the camera and you can get a better view. That's this is a better view. I'm going to be probably blocking the camera, but if I move here, that should be okay. You can see the camera. All right, so here goes. So all of these all have again 30 million each of them. I'm running the experiment in triplicate. So trial, for experiment one, experiment two, experiment three, replica of the same experiment, making of a tripeptide being catalyzed by an organometallic catalyst, chromium picolinate, and I'm adding glutamine, arginine, and lysine in all of the compartments of the micropipette. Look how handy, science, engineering and scientifically creative this became. This whole tip from Igen Corporation. All right, so okay. So we're gonna go. I can go off the camera because then. Each of them will have one. Stir. Have a spoon. All right. So then, so you all know peptide bonds, CONH, two amino acids combined together, the carboxyl and the amine group from each amino acid combines with the carboxyl group from one amino acid with the amine group from the other amino acid. All right, so did I lose count here? Okay, and lysine. So the ends in of each protein, one end would be a carboxyl group, and the other end of the protein would be amine group, because that's how amino acids combine. I've made collagen. Remember, it's on my LinkedIn webpage. It's best to add heat or a catalyst. I hadn't added a catalyst, but I had added. And this is here. Okay, so let's begin the experiment. Stir first. So catalyst, chromium picolinate. So organometallic reactions, as I studied the last time when I did it, with the in front of you. So, and I made the calculations, have a whole different kinetics. You need to read Mizzen, Mims, and Salute, and that gives you typically organometallic catalysts result in polymerization reactions, and the simulations predict that. But I did not have polymerization, and also I had ammonia, and then so I'm going to turn on the exhaust, and so just in case. But typically, a tripeptide should result from three amino acids being combined together. Or if you give heat, you don't even need a catalyst. For fun, I'm adding the catalyst. You could look at the lowering of activation energies happens through via enzymes or via heat, and but then adding thermal the thermal variable means it becomes other issues could arise. I mean, it becomes hot and that sort of thing. Yeah. So all right, so stir, stir, stir. So same spoon, same reaction. Beginning the reaction. All right, so stir, 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 stir. So every 3 minutes apart, sampling intervals. Micropipette trick. What do I miss? I miss the micropipette. Just dip in with a cube with a micropipette tip. Take a sample, and voila. I didn't even turn the exhaust. Turn the exhaust. Just in case. I'm so careful this time. Somebody has some kind of antenna. I'm running the experiment. They call up. Yeah. 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 So actually, it would be interesting to calculate the intrinsic effects, mass transfer from the capsules, right? The rate of mass transfer could be. So it's just a fixed law of diffusion, and this is osmosis or diffusion, and a whole worked out solution and everything, which I submitted to even the YouTube hit along with Mrs. Sundar. Maybe just do this one. Yeah. All right. It's 2/3, 2/3, 25, 2/3, and we'll check this out. 25, 2/3. 25, 2/3. So far, so good. Yes, stir, stir, stir. Next sample is at stir, 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 stir. All I'm doing is stirring. So, time, that's time. We can do this. 10 more. All right, by the time I'm done, it's going to be a few seconds. So sampling 2. So 25 1/3. And 1/3. This is 1/3. So again, plus or minus confidence interval. This is showing more. 25 1/3. Plus or minus confidence interval. And the permeability, right? Some capsule will, the exterior may be a little, the capsule may be, no idea, maybe, the maybe some capsules. Minutes, it started 6 minutes. 25 and a half. So 25 grams divided by 2, 12.5 grams. And some of 25 grams. These capsules are not very well made. They break open. 25 and multiplied by half. Okay. Maybe we did this one for a change. Different just measuring cup, different measuring cup. Three and zero. 3 minutes and zero. And I'm all done. So three amino acids. Oh, actually, I'm making a peptide. It's two amino acids, or a dipeptide is two amino acids. Three amino acids. So it's one extra. So two peptides, dipeptide bond is two amino acids. Tripeptide bond is three amino acids. That's correct. All right. Or a peptide bond is two amino acids, I think. I'm given it incorrectly. So makes sense? So two amino acids combining together make a peptide bond. Three amino, so this is a dipeptide. I'm making a dipeptide. So dipeptide. So there's three amino acids. It would result in two CONH bonds. And you would have the on the one side NH3 or NH2 plus, and on the other side COOH. I always feel comfortable saying carboxyl first for some reason. Logically, amine A and then carboxyl C, and all right. So 3 minutes. Let's do the measuring. Measure, measure, measure. All right. We are going to. This is 1/3. We are dropping. Reverse reaction. Okay. 1/3. So if you were to take a density of a mixture reading and calculate balancing the equation, you would 1/3. It's all consistent. All the three reactions, or all the three experiments are Okay, once the timer goes off, last reading and A-OK. Coming along well. I think I'm releasing some gaseous, never goes according to plan, does it? Huh? Tripeptide, maybe an enzyme, what? A peptidase? Is there peptase, peptidase? I think this is enough stirring for this. I'm making, gaseous products. Let me just see if there's a peptidase enzyme. Peptidase, peptidase, peptidase. There is a peptidase versus protease breakdown. Oh no, no. These both break down proteins, peptidase and protease. They break down proteins. Okay. There's a bit of a time delay on my timer. Yeah, time delay on my timer. It has to be fixed, I think. How would you fix a time delay on timer? Hmm. Set your watch faster or slower, faster. Okay. Okay. And this turn. If I want that, and I this is also 25 one thirds. No, no, this is going down. It's in progress. Reaction is in progress. This is 25 one thirds. More like 1/5, but let's not split hairs here. Or split more of the peptide into make it into carbon dioxide and ammonia. I think 1/5. This is 1/5. All of these are 1/5 because it's really close to them. So these are my results, and I'm going to be doing some kinetic study on this, the organometallic reaction, which is outlined in Misen Mims and Sibyl, and see how that works for me. Or maybe that's too much. I got all. I mean, the reaction progressed well. If I just figure out if I made the dipeptide, not tripeptide, dipeptide, dipeptide. Try. Not happening. Oh my God. Never say die. Die is not right. Or DYE. No, that's a good one. I was thinking of dyeing feathers now because I'm going to make a dream catcher with the web in there as DNA. Never before done. My son's coming on this Thursday, late in the night. Maybe his flight's late. So God, but I have to be ready. What if he comes early? What if he changes the flight? Right? So anyway, so that's my result. So this is dipeptide, making of a dipeptide, Dipeptide. Typically in engineering, we don't say di-tri, but tri seemed so good, right? Tri, well, that's something for me to explore. Making of tripeptide. The next time. Signing off, Gayatri Sitaram. Thank you. So maybe I'll do the mass transfer, telemodulus, and etc.